Okay, let's do some relative velocity problems here. A boat that can travel with a velocity of 12 meters per second in still water is moving at a maximum speed against the current of stream that flows with a velocity of 5 meters per second relative to the earth. What is the velocity of the boat relative to the bank of the stream? Let's draw a picture. We have a stream. It's a nice stream. Okay. And this is the bank that the stream is near. Nice bank here, I don't know. Let's drop more water. Okay, so in this stream is a boat. Here we go with the boat. Didn't say it's a sailboat, but I'm making it a sailboat. Alright. You can also be a motorboat. Let's put a little propeller on it. Okay, so the boat can travel 12 meters per second. So let's put that on it. It's going to go that way, 12 meters per second. Alright. The current of a stream that flows with a velocity of 5 meters. So it's going 12 meters per second against the current. The current is going at 5, let's highlight these, at 5 meters per second. So the water, the current is going 5 meters per second that way, relative to the earth. What is the velocity of the boat relative to the bank of the stream? So it's going 12 meters per second in the water, not relative to the bank. In the water, it's going 12 meters per second. It's just going as fast as it can. That's what its propeller is shooting out at. The stream, though, is saying, well, I'm going this way. The boat is going in the stream. So the current's going to push against the boat. And we have to subtract those two vectors. Okay, so we got to have 5 this way. We have 12 this way. So really what we observe from the stream is the difference here. This is what we would see from the stream. We'd see this 12 minus the 5 meters per second. We'd see the boat going at 12 minus 5. That's meters per second, that's meters per second. And that's what we would see from the bank. So that's one way to set up one of these problems. Another way is, look at this one. A swimmer swims upstream with a velocity of 4 meters per second relative to the water. So we got water here. We got a guy swimming. Alright. So 4 meters per second relative to the water. The velocity of the current is 3.5 meters per second downstream. So the water is going 3.5 meters per second downstream. What is the velocity of the swimmer relative to the bank? Okay, so relative to the water he's going 4, but relative to the bank the water is going 3.5. So really, relative to someone on the bank, someone sitting over here outside of the water, they would see this 4 meters per second, subtract the 3.5, and that's what they would see on the bank. Because you have this vector going this way, that vector going that way. The total that we'd see on the bank over here would be the subtraction. And you can kind of think of it like the water's pushing against the guy, or you can think of it as the guy's in the water. He would normally be moving 3.5 meters per second to the right, but he starts swimming at 4 meters per second, so he picks up a velocity going that way. Okay, So the important thing is you have to draw out these problems. You have to look at where the arrows are going. I could do even more, but I'm just going to ask you simple ones like this. If you draw out the arrows and say, okay, this one's going to the right, this one's going to the left, you know you got to subtract them. That's the major thing to find the resultant.